Assalamualaikum and good morning. I am Nurhanani binti Moktar will be presenting experiment 1, acid-base titration. What is neutralization? It is actually a process in which acid react with base to form salt and water. There are 4 types of titration which involve strong acid, strong base, strong acid, weak base, weak acid, strong base, and weak acid, weak base. But in this experiment, we only use 2 types of titration, which is strong acid, strong base, and weak acid, strong base. The important in neutralization process is the changes in indicator, because it shows the substance had reached the end point of a titration. The common indicators are phenolphthalein, methyl orange, and prothymol blue. Okay, these are the formula for molarity, volume, and moles. We can manipulate the above formula MAVA or MPVB to calculate or to find the molarity or volume of acid or a base. The A and B is the coefficient of the acid and a base, and the below formula is for moles. But remember, if the volume is already in liter, do not include the thousand. Alright, these are the methods to calculate pH for strong acid and strong base, and also weak acid or weak base. There are differences because for strong acid and strong base, we use the pH is equal to negative log of concentration of hydronium ion, and for the pOH, we use the negative log of the concentration of hydroxide ion. But for the weak acid and weak base, we use ice table with a known of Ka value. But this is only applicable for theoretical pH. For the experimental one, usually the students or the lab instructor are use pH meter to obtain the pH value. Moving on to the titration curve for strong acid and strong base, we can conclude from this curve is we can see from the curve the equivalent point is at 7, and therefore the suitable indicator for this curve is prothymol blue and phenol red, because the 7 lies between this value, and the indicator can signal the acidity and the alkalinity by changing the color. The example for strong acid, strong base is titration of hydrochloric acid with the sodium hydroxide. And the last one is the titration curve for weak acid and strong base. From this curve, we can conclude that the weak acid has a higher initial pH, which is 3, and the pH increases rapidly at the start. So you can see 3, 5, and then 7, and then it becomes slow near the equivalent points. In this case, the equivalent points is set at 9. So the suitable indicator for this weak acid strong base is phenolphthalein, because 9 lies between the 8 and 10. So the indicator can signal the acidity and the alkalinity by changing the color. The example for weak acid and a strong base is titration of ethanoic acid with a sodium hydroxide. I think that's all from me. Thank you.